How to make gear hobs in the home workshop. Allow me to present to you this simple yet effective apparatus, with which one may fashion all manner of cog and gear wheels. Such as may be found in automobiles, industrial machinery, and modern labour-saving devices. This is done by making use of a clever device known as a gear hob. A fearsome looking fellow, but don't be daunted. You too can make one in your own workshop. First, obtain a length of carbon steel rod from the local blacksmith or hardware emporium, of the type that may be hardened and tempered. About an inch diameter should suffice. You will also need a lathe cutting steel, which needs to be ground to the correct shape. But how do we determine that shape? Well, let's take a look at this large wooden facsimile of a gear wheel. The circle indicated is called the pitch circle and is the working diameter of the gear at which it meshes with any other gear. The angle of the tooth where it intersects with the pitch circle is called the pressure angle. This angle is 14.5 degrees and is the angle to which we must grind our cutter, 14.5 degrees each side, or a total angle of 29 degrees. This can be done on the bench grinder in less than one afternoon. Steady on. That cutter now has a sharp point which simply won't do at all. It must have a flat point. Some calculations must be done to determine the width of the flat. Gears are defined according to the diametral pitch system, not to be confused with the diametrical system. The diametral pitch of a gear is the number of teeth it has per inch of diameter of the pitch circle. For instance, a 16 dp gear of 3 inches diameter would have 48 teeth. Looking more closely at the gear teeth, the height the teeth project above the pitch circle is referred to as the addendum. This distance is equal to 1 over the diametral pitch, or for our 16 dp gear, 1/16 of an inch. The distance between the pitch circle and the bottom of the teeth is known as the dedendum and is equal to 1¼ over the diametral pitch, which for our 16 dp gear is 5/64. These two added together give the total height of the tooth, in this case 9/64. Let's look now at the hob that cuts this gear. The teeth are straight-sided like those of a rack. The tooth depth is 9/64. The addendum and dedendum must be reversed. The spacing between the teeth is equal to pi divided by the diametral pitch, 196 thousandths of an inch. The width of the tooth on the pitch line being exactly half of this, 98 thousandths of an inch. The flat on the inside of the hob, which corresponds to the flat on our cutter, is this width minus these two distances. Using trigonometry, it is possible to calculate these widths and deduce the flat width through the use of sine and cosine tables. it comes to 66 thousandths of an inch, or to put it in plain English, 8½ 128ths. Much better. But how are we to measure something so tiny? None of the standard measuring methods seem to work. Fortunately, we can use a technique known as the newfangled ball bearing trick. The cutter is placed upside down against a straight edge, and 2 1/4-inch steel balls are placed either side of it. Through the use of trigonometry again, it is possible to relate the width of the flat to the distance across the 2 balls, which may be more easily measured with calipers and gauge blocks. That done, we may start the process of machining the hob on the lathe. The normal screw cutting technique is employed, with the pitch set to 196 thousandths of an inch as calculated earlier. The final depth of cut being 9/64ths. The teeth may now be gashed on the milling machine. The hob is hardened and tempered, and the final edge given with a stone. It is now ready for the hobbing of all manner of gear wheels from modern high-performance engineering materials such as iron and cast iron,